Hello everyone, I am Narendra. The title of our paper is Journey to the Center of the Words, Word Weighting Scheme based on the Geometry of Word Embeddings. The co-authors of this paper are Krishna, Reddy, Amit, Pandey and Naresh Manwani. We are from IIIT Hyderabad, India. This work is related to the area of text mining and text representation, specifically word representations and word sequence representations. The important keywords that I would be using throughout this presentation are word embeddings, sentence embeddings, word weighting scheme, semantics, textual similarity. Now let's talk about the meaning of the words. Words are the smallest and meaningful units of the natural language. Larger text units such as phrases, sentences and documents are further composed of words. So to make a computer understand any language, knowing the words of it has a key role in it. Regarding the meaning of the words, distributional hypothesis is the most popular theorem. First stated it as a word characterized by the company it keeps, and Harris stated it as the words which occur in a similar context will have similar meaning. Overall, the meaning of word can be improved by examining the context it occurs in. Consider two sentences, I enjoy running and I like running. According to the distributional hypothesis, the verbs enjoy and like have the similar meaning because they are occurring in the similar context. Operationalizing the distributional hypothesis, several neural word representation models are proposed and popularized as word embeddings. Word embeddings are nothing but word representational vectors positioned in a feature space such that contextually similar words are put closer to each other and unrelated words are put far away from each other. For example, consider this sample space where the words related to the fruits, apple, banana, mango, they are all close to each other, and the words related to the vehicles, car, jeep, plane, they are close to each other. But as concepts, vehicles and fruits are different from each other, so they are kept far away from each other in the word embedding space. So it can be understood that the semantic relatedness of the words is proportional to the spatial proximity and inversely proportional to the distance. The important properties of word representations obtained from word embeddings are they are fixed length, real valued, and they are represented in low dimensional feature spaces, and they are dense featured, as well as they are trained in huge corpora in an unsupervised setting. Because of this, they encode a lot of linguistic regularities and solid syntactic and semantic information. And also, the continuously improving models are coming up to improve the quality of word embeddings, such as go-to-vec, glove, elmo, and BERT. Because of all these advantages, they are used in many downstream tasks such as name identity recognition, POS tagging, classification, and information retrieval. Now let's talk about sentence embeddings. With the success of word embeddings, now many works are focusing on extending the concept of embeddings to the word sequences such as sentences. The works related to the sentence embeddings can be classified as two types: complex deep learning models, which uses convolutional, recursive, and recurrent neural network architectures and learns sentence embeddings from the scrap. The other type is simple composition models like vector averaging, which takes word embeddings as input and combines them through some mathematical function and produces word sequence representations. Simple vector averaging produces sentence embeddings by simply averaging the embeddings of words occurring in that sentence. Many works shown that simple vector averaging performs better than complex deep learning models. The success of this model is attributed to the geometry of word embeddings, because the geometry of word embeddings contains a lot of syntactic and semantic information. In this work, we present an average-based compositional model for sentence embeddings. Even though simple vector averaging is proven to be effective, it has the drawback of assuming equal importance to all the words in the given sentence. But in reality, we know that different words possess different degrees of information content. For example, word the, it is very common word and it doesn't convey any particular concept. But the word database, it gives an impression that the text is talking about computers and information systems. So by assigning weights to the words based on their discriminative power helps in building better sentence representations. In literature, there are many frequency-based word weighting schemes. The basic principle behind these schemes is the more the frequency of word is, the lesser the information content it possesses, and therefore the lesser the weight of the word should be. For example, TF-IDF, it considers how many documents or sentences the word occurred in, and the SIF, a smooth inverse frequency method, it considers how many times a word occurred in the corpus. Based on these frequency statistics, they assign word weights. The frequency-based word weighting schemes derive word weight solely based on the number of times a word occurs in the corpus and ignores the diversity of contexts it occurs in. In addition to the raw frequency information, the contextual diversity of word also has important information about its discriminative power. So we propose a weighting scheme which captures the contextual diversity. The basic principle of proposed weighting scheme is that a word that occurs in many different contexts, that is having high contextual diversity, is a generic word and it has less discriminative power. And a word that occurs in consistently similar contexts, that is having low contextual diversity, is a domain related word and has high discriminative power. This can be summarized as the degree of bias or skewness in the diversity of a word's context is an indicator of its importance. Contextual diversity properties of words are captured by the word context co-occurrence statistics. The word embedding models transform these co-occurrence statistics into the geometric representations. So we made an effort to analyze the spatial distribution of words in the word embedding space and derive a special spatial measure that captures the contextual diversity. From the analysis, we observed that general words are kept closer to the centroid of words and the domain related words are arranged far away from the centroid. So as the word's distance from the centroid increases, its contextual diversity decreases, domain specificity increases, and so the discriminative power increases. We name this special spatial measure that captures the contextual diversity as the local norm. The local norm of a word is nothing but its distance from the centroid of all the words in the vocabulary. The more the local norm of a word, the more the discriminative power it has. So in the proposed weighting scheme, we define the weight of a word as its local norm value. Now I will briefly discuss the mathematical analysis that is used for derivation of local norm measure. For this, we consider a vocabulary of n words where each word will have a set of related words and set of unrelated words. Here, the objective is to operationalize the distributional hypothesis for these n words. In other words, we seek to generate an embedding space for these n words where the related words are close to each other and the unrelated words are far away from each other. For this, we define a generic cost function which minimizes the mean square distance between the related words and maximizes the mean square distance between the unrelated words. To learn the word embeddings of these n words, we use gradient descent optimization algorithm where the word embeddings are randomly initialized first and then iteratively updated. The update equation we derived by calculating the partial derivatives over this cost function is as this: W new equal to W old plus eta times mu minus mu sigma. Here eta is learning rate, mu is mean of related words of W, and mu dash is mean of unrelated words of W. From the update equation, we can understand that with each iteration, a word is updated towards its related words mean and away from mean of unrelated words. So with each iteration, a generic word moves closer to the centroid and a domain related word moves away from the centroid. So the local norm captures the domain specificity of a word. To illustrate this theory, we consider a toy data set which contains 4 sentences. What is the time? What is the day? What time is the meeting? Cancel the meeting. The vocabulary formed by these 4 sentences contains these 7 words: the, what, is, meeting, time, day, cancel. Here we consider a pair of words as related if they co-occur in at least one sentence, and a pair of words unrelated if they are never used in the same sentence. So from these sentences, the has, what, is, meeting, time, day, cancel as related words, and it has no unrelated words. Similarly, we can observe for all these words we have related words and unrelated words. We train a simple model on these sentences that optimizes the error function that we discussed earlier. First, for all the words in the vocabulary, 2-dimensional embeddings are initialized randomly, and then stochastic gradient descent algorithm is used to learn the word embeddings with the update rule we discussed earlier. The update equation ensures that the word vectors are close to their related words and far away from the unrelated words. The figure illustrates the learned embeddings in the 2-dimensional space. In this figure, we can see the 2-dimensional representation of words, and for reference we have also drawn the centroid of these words. From the figure, we can observe that the most generic word the, which is related to all the words, is closest to the centroid. The words is and what have the same set of related words and unrelated words, so they have the same, almost the same representations. The words day and cancel can be considered as domain related words as they are related to few words and unrelated to many words. So in the word embedding space, they are placed far away from the centroid as they are contextually skewed. The words meeting and time occur equal number of times in the corpus. So the frequency based approaches gives equal weightage to these two words. However, the meeting co-occur with domain related word cancel. So it is contextually skewed compared to the time. According to the proposed weighting scheme, meeting gets a little more weightage compared to the time. Overall, the gets lowest weightage, what is meeting and time gets medium range weights, day and cancel gets higher weights. Now I will discuss the denoising steps which we use along with the proposed weighting scheme to generate the sentence embeddings. Noisy words are the words which happen to occur in the given corpus but are actually irrelevant to the concepts discussed in the corpus. So they possess very little relevant information content related to the concepts discussed in the corpus and are usually not good representation features. Noisy words are unrelated to most of the words in the corpus, so the distributional hypothesis advocates them to position them far away from the rest of the words in the corpus. Consequently, the proposed local norm weighting scheme gives higher weights to these noisy words as well. So it tends to exaggerate the noisy components in the sentence embeddings and it demands denoising. As the noisy words are far away from the centroid, they have the longest projections in the principal component analysis. Therefore, the initial principal components of the word embedding space captures the noisy components. So denoising of embeddings can be performed by removing initial principal components from the embeddings. Here note that it is very counterintuitive because the traditional dimensional reduction techniques removes the weakest directions. However, here we are removing the strongest directions from the embeddings. Denoising can be done as a pre-processing step and as a post-processing step as well. In pre-processing step, the word embeddings are cleaned first and then they are used to generate sentence embeddings. And in post-processing step, the dirty word embeddings are used to generate the sentence embeddings and these sentence embeddings are purified later using denoising step. In our work, we are using post-processing step as main step and pre-processing step as an optional step. The proposed local norm weighting technique captures a special property and the frequency based weighting schemes capture a statistical property. As these two capture two different properties of words, in this paper we propose hybrid weighting techniques to combine both the varieties. The proposed three weighting techniques are weights addition, vectors addition and vectors concatenation. Now I will discuss the experimental setting. We evaluated our sentence embedding method and semantic textual similarity task with a total of 23 datasets. STS datasets contain multiple pairs of sentences with each pair annotated with a semantic similarity score on a scale of 0 to 5. The objective of STS task is to predict the similarity score for each pair. The evaluation criterion is Pearson quotient between the predictor scores and the ground truth scores. We evaluate our method against both supervised methods and unsupervised methods. Coming to supervised methods, paragraph phrase projection, deep averaging network, identity RNN, LSTM and infercent are used. In unsupervised methods, skip thought, Dynamax, word most distance and better score method is used. Coming to average based unsupervised methods, all but the top, term frequency, inverse document frequency, which is nothing but TF-IDF, smooth inverse frequency, SIF, and unsupervised smooth inverse frequency, USIF is used. Now I will briefly discuss the experimental results. For pre-trained word embeddings, we use standard glove and go-to-vec models. Coming to comparison study, our local norm sentence embedding method outperformed most of the complex deep learning based methods on almost all the datasets even without any task specific fine tuning. Also, it outperformed non-averaging based compositional models such as word most distance, bet score and Dynamax. Compared to the simple vector averaging, the performance gain of the local norm weighting technique is 31% in case of glove and 16% in case of go-to-vec. The local norm method outperformed frequency based methods such as TF-IDF and SIF. And also it performed comparatively with the current state of the art weighting scheme USIF with the average difference margin being less than 1%. By combining local norm method with the three frequency based methods TF-IDF, SIF, USIF through three merging techniques proposed, weights addition, vector concatenation, we proposed 9 hybrid techniques. Average, the hybrid weighting techniques outperformed their individual techniques by about 2 to 3% and achieved highest scores on almost all the datasets. In the paper, we have also presented ablation study to understand the effect of the denoising techniques and the qualitative analysis. Coming to feature work, in the current paper, The proposed weighting scheme, along with the post-processing denoising step, has been employed as a sentence embedding method. However, fundamentally, the proposed weighting technique identifies the most important words or the keywords from the given content. So, it can be used as a keyword extraction technique as well. Extracting keywords is employed in a wide range of tasks such as text indexing, categorization, summarization, ranking, and search engines. Frequency-based approaches such as TF-IDF weighting technique and other variations of it dominated this direction of research. As part of our future work, we plan to extend this work and leverage local name as a competitive alternative or complementary approach to the frequency-based approaches employed in the above mentioned text mining and information retrieval tasks. Thank you. Feel free to ask any questions you have.